We're now going to turn our attention to the splitterator. And we've looked at some simple splitterators before, but now we're going to look at a much more interesting and powerful splitterator. And this will serve as the basis for our parallel streams discussion that we'll do probably starting either later today or early next week. I'm going to focus on the implementation of the search for phrase method, which, as you'll see, will end up creating a stream in order to be able to find what phrases match in a given input string, in a given work of Shakespeare. And so here's the way this is going to work. We're going to use a class called PhraseMatchSpliterator. And this PhraseMatchSpliterator is going to work for both sequential and parallel streams. We're going to focus right now only on the sequential version, which will break things up into one chunk. But then when we talk about parallel streams soon, we'll talk about how we can use the same splitterator to break things up into multiple chunks. And I'll talk about why I have pictures of broomsticks when we get to that point of the discussion. Here's what the method looks like. Search for phrase is the one that takes a list of phrases, converts it into a stream of phrases, and then for each phrase in this stream, it will go and look up in a given input string, like a given work of Shakespeare, like Hamlet or Julius Caesar or Macbeth or whatnot. And it'll find all the matches of that phrase, if any, in that work of Shakespeare, and we'll end up with a stream of matching phrases that are search results that indicate where the match occurred. The actual implementation is pretty interesting. What we're going to do is, as you can see, we take a bunch of parameters. We take the phrase we're looking for, the work of Shakespeare, the title of the work of Shakespeare, and then a Boolean that says, do we want to run in parallel or not? For now, we're not working in parallel. And then we're going to go ahead and use the streamSupport.stream method. And if you recall, streamSupport.stream is a factory method that will create either a sequential or parallel stream using a splitterator. In this particular case, we're going to make a sequential stream. Later, we'll make a parallel stream with the same exact code. And the stream will be made by creating a splitterator, which is called PhraseMatchSpliterator, that we're going to look at in a second. And that is going to be given an input string corresponding to the work of Shakespeare, any given phrase, and it will make a stream of things that match. So we'll have a stream of these matching results, which are search results, and then we collect them all up into a list, and that gets stuck as the fifth parameter to search results. Okay, so that's kind of the big picture view, anchoring what we're about to talk about in the context of this example. This is where it occurs. As you can see, we take a stream of strings, which correspond to the search phrases. Search for phrase converts them into a stream of search result objects. So that's where that piece of code occurs, and it uses a splitterator under the hood to do this. Here's what we're trying to do. We are going to search through the input string, and anywhere we find a match for the phrase, we're going to create a search result, which will be put into the stream of search results. So if we were looking for the phrase, brevity is the soul of wit, and we gave it the Hamlet text, it would match at that index into Hamlet. So here's what the splitterator looks like. We talked about splitterators before when we talked about the simple SearchGang, but this is a much more sophisticated use of splitterator. And so we have a lot more fields involved. So this is going to use a regular expression to make a stream of search result objects, result objects, that match the number of times a phrase appears in a given input string. So, of course, PhraseMatchSpliterator implements the splitterator interface. And as we'll see, or as we've discussed, splitterator is an interface that contains a bunch of methods like try, advance, and split. And we'll talk about those in a second. There's a bunch of fields here. For example, we have we'll go through each of the fields. Some fields are private. Some fields are updated in another method, which we won't look at the moment, called try_split, which is why we don't make all of these fields final. They're all private, but some of them are final, some of them are not, because some have to be updated later. The minput field is a character sequence that contains a single work of Shakespeare. Mphrase is a given phrase we're looking for in that input, in that work. Mpattern is the regular expression, a compiled regular expression representation of the phrase we're searching for. We'll look at that in a second. It's very important to get that right. That's probably the most complicated part of this implementation. PhraseMatcher is a matcher that associates the regular expression pattern with the input file. So that gives us a pattern matcher. That's very important. Luckily, all that stuff is kind of hidden from you as an implementation of regular expressions in Java. And then we also keep something called a min split size, which says when we do parallel streams processing, where are we going to consider the input file to be small enough that we don't break it up into further chunks. And we'll talk more about that shortly. OK, so those are basically the fields in the class. Now we're going to talk about the actual implementation.